This is lesson 7-7, and it's on equivalent fractions. The objective today is that the students, will be able to use some math reasoning, problem solving, to find equivalent fractions and then check them through a process called cross multiplication. So we have a couple of goals today that go very well together. All right, in order to succeed in this lesson, you're going to need to know a couple of things. Number one, you're going to have mastered your multiplication facts. If you don't know your multiplication facts, this lesson is going to be extremely difficult. The other thing is, if I say the numerator and denominator, you should know in your head immediately what parts of the fraction that I'm talking about. If you're at all unclear about either one of these two things, please review them before you continue with this lesson. This lesson is really important. It's a key lesson in knowing how to add and subtract fractions with unlike denominators. New fifth grade skill, and it takes a few steps, and this is one of them. All right, here's our notes. What are the steps in finding equivalent fractions, and how should I verify my answers? And again, you're going to be writing down the notes as you go, bring them to class, and so I can review them, and then we can use them later as we're studying for the test. All right, so there's a couple of things that you need to know before we launch into a couple of guided practice problems, and that is you need to know a little bit about equivalent fractions. So I'm going to give you a fraction to start off with. It's called 3/4, and we're going to find an equivalent fraction of 3/4 with a new numerator and a new denominator. The new numerator and denominator are going to be different numbers, but they're going to be exactly the same value as 3/4. All right, so the thing that I know about fractions is that if I multiply the denominator by something and I multiply the numerator by something, I will get a new numerator and the new denominator. Now that something that I multiply has to be the exact same thing. So I'm going to show you an example where I multiply the numerator by 5 and the denominator by exactly the same thing. If I do that, I will have equivalent fractions. 3 times 5 equals 15. 4 times 5 equals 20. And now we have equivalent fractions. 3/4 equals 15 over 20 in value. So how do I know that the value is correct? Well, there's a process that is called cross multiplication, and that is where you take the numerator of one number, multiply it by the denominator of the other number, and that should equal the denominator of one number times the numerator of the other. All right, why do they call it cross multiplication? Because when you multiply these two together, it forms kind of a cross in the middle. All right, so let's find out. Does 3 times 20 equal 4 times 15? 3 times 20, does that equal 4 times 15? 3 times 20 is 60. 4 times 15 is 60. 60 equals 60. Check. So there was a couple of things going on there. One is that we know a little bit about equivalent fractions now. If I take the numerator and the denominator and multiply them by the same number, I will have equivalent fractions, and I can check that equivalency by doing cross multiplication. All right, so today's lesson, though, is going to be slightly different in that you're going to have to do a little problem solving on figuring out what do you multiply by the denominator or the numerator to get your new fractions. And the reason why you're going to need to do problem solving is because you will know one fraction and you'll know half of the other fraction. All right, so you might see something like this: 5/8 equals blank over 24. And we have to figure out what goes there, what number would be appropriate there to keep these fractions equivalent. So here's your problem solving. I know that 5/8, if I took the 8 and multiplied by something, I would get a new number, and if I took the 5 and multiplied it by something, it would be another new number here. What do I multiply by, though? All right, here's the problem solving. You know the fraction 5/8. You know the two denominators, so let's start with the denominators. 8 times something equals 24. We have to figure out what is that something. 8 times 3. 8 times 3 is 24. And so to maintain equivalency, to find out the new number, I'm going to take the numerator and multiply it by 3. So 5 times 3 equals 15. Now, is that equal? Let's find out. So it would be 8 times 15 should equal 5 times 24. So 8 times 15 and 5 times 24, are they equal? 8 times 15 happens to be 120. 5 times 24, 120. And that's been verified. Okay, so this is the problem solving that we have to go through. Sometimes we have to figure out what to multiply to get a new numerator or new denominator, and then we're always going to be verifying using cross multiplication. We're going to be replacing each one of these gray squares with a number that's going to make the fractions equivalent. All right, so if you haven't already done so, please get out a graph paper and follow along. So the first thing we're going to be doing is writing out the fractions. 3/4 equals 21 over blank. Now, you're always going to be moving in the direction, you're problem solving, from the fraction that you know both parts of towards the fraction that you only know a little bit of. And we're going to be doing the problem solving by relating either the numerators together or the denominators together. And in this case, we have two numerators, and so we're going to be relating them together. Relating them means we're going to, figure out how they're related. 3 is related by 21 through multiplication. 3 times something equals 21. And if you've done the problem solving in your head, it's times 7. Now, to get the new denominator, I have to multiply the denominator times the same thing I multiplied the numerator by. And that's going to give me equivalent fractions. So 4 times 7 equals 28. 21 over 28 equals 3/4. Does it really? Well, let's cross multiply. So we take 3, which is the numerator here, times 28, which is the denominator on the other side. So you have 3 times 28. Does that equal 4 times 21? 3 times 28 happens to be 84. 4 times 21 happens to be 84. Check. Verified my answer. Now, what if you can't do 28 times 3 in your head? How long is it going to take you to do this? Not long, right? So the fact that I'm doing it in my head is just for speed. Okay, I want you to be accurate. Make sure that you're doing it on the paper. All right, so here's practice problem number 2. This time we know the fraction on the right side of the equation rather than on the left side of the equation. So when we move in our problem solving, we're going to move from left to right this time instead of right to left like we practiced before. So rewriting the fraction, it's blank over 4 equals 12 over 16. And now we're going to relate the denominators because I know both of the denominators. And again, moving from the fraction that is complete to the fraction that you know part of. 16 to 4. 16 to 4 means numbers are getting smaller, so that means a division problem. 16 divided by something equals 4, and happens to be 4. So 16 divided by 4 is 4. I have to do the same operation with the same number to the numerator to keep these fractions equivalent. Oh, I wrote multiplication. Don't want to write multiplication there. It's a division problem. 12 divided by 4 equals the new numerator. So 12 over 16 equals 3/4. Let's cross multiply to find out. So cross multiply is denominator times numerator, which is 3 times 16. That should equal this denominator times that numerator, 4 times 12. 3 times 16 equals 48. 4 times 12 equals 48. 48 equals 48. And you have verified that as the answer. All right, one last guided practice problem, and then we're going to figure out some common mistakes, but also what are you going to be doing today out of your workbooks. All right, once again, similar type of problem. Rewriting the fraction to start with, 2 over blank equals 12 over 18. And again, we know the fraction on the right, so we're going to be working from the right to the left in our problem solving. And we know the 2 numerators this time, so that's where we're going to start our problem solving. 12 is related to 2 in some way. Well, the numbers are getting smaller, so it's going to be divided by something. 12 divided by something equals 2, and that something happens to be 6. So in order to maintain equivalency, I have to divide the numerator and the denominator by the same thing. Numerator was divided by 6. Denominator must be divided by 6. So 18 divided by 6 equals 3. All right, that's it. So cross multiplication to verify, that's 2 times 18 equals 3 times 12. 2 times 18 equals 36. Does that equal 3 times 12, which is 36? Check. Let's take a look at our common mistakes that a lot of people make. And the common mistake is working in the wrong direction. Right? Remember, there's a flow of direction that you have to work in. And you work from the fraction that you know completely toward the fraction that is missing a part. And some people just don't do that. Okay, so they have blank over 4 equals 9 over 12. And they're used to working from left to right. So they do that. They don't draw an arrow. They just connect the 2 and they say, okay, that's times 3. Right? And then they work from this side to that side and they say, hey, that's times 3. So 9 times 3 equals 27. And that is wrong. If you verified it, 27 times 12 does not equal 4 times 9. Right? So if you did cross multiplication, you would find a huge mistake there. But that is something that happens a lot. Remember, if you have a complete fraction, you're going to be working from that complete fraction in the direction of the fraction that you don't know. So if I work from the 12 to the 4, I have to draw an arrow to the 4, showing that's the flow that is going to be happening here. So 12 turning into a 4 would be not times 3, it would be divided by 3. And at that point, you can do 9 divided by 3 and get 3. Right? This would be incorrect. This one would be check, corrected. So to do, we're going to be doing H7-7, that's out of our homework book, and we're going to work on problems 1 through 14, only the even problems. And here's your reminder. Verify all your answers by cross-multiplying. If you cross-multiply and you don't get the verification you want, you got to start over. Okay, good luck.